Greetings everyone. So this is in lieu of the EV Powertrain design presentation for EV Development Program 2023. So moving on with team objectives. So this year we have included calculated new values for the powertrain department as well as in the electrical department uh, for component selection according to those newly calculated and simulated values, which also helped us in selecting proper rated components with accurate calculations as well as also selecting a proper BMS. So the technical specifications are to the nominal torque of the motor is 9 Newton meters and the peak torque is 90 Newton meters. The nominal motor speed is 3300 RPM and the peak speed is 5800 RPM. So to say a least, the base voltage of the system is 72 volts and the peak current rating is 230 amperes, and also the overall capacity of each cell is 75 amp hours. So here is the normal design flow of our EV powertrain development. So first we start with modeling simulation. After that we select constants and variables for simulation. We have selected a pre-made drive cycle, that is FTP75. Also after that we have created blocks to simulate it in MATLAB Simulink. After simulation we got graphs. On the basis of those graphs we have uh, graphs and different improvisations. We have selected various part and components. After that selection of the components, uh, this year we have adopted a smart BMS system for monitoring different components of our accumulator and overall EV powertrain. After that we procured the final component list. Okay, this year we have used softwares like Scilab, ANSYS, Scilab and MATLAB for uh, Simulink for designing different modules, and ANSYS for simulating heating cooling system. So these are the various values used in simulation. The motor is 85% efficient. The converter's efficiency has been increased from 90 to 92%. Transmission efficiency has been increased from 73 to 75%. Moving on the drive cycle. So this year we have used a predefined drive cycle, that is FTP75, because it was chosen keeping in mind it met the certain criteria and conditions of the Formula track, which we are going to take part in. So that's why we've chosen it. Moving on, the simulation details. All right. Let's start with chassis. The transmission, all that part is located in the rear end of the vehicle. The motor is attached with the transmission and it is being supplied with the battery, the accumulator pack. So these are the various motor calculation. As we can see, we have given diagram. We have simulated these in Scilab, all right, to calculate the motor speed and motor torque. The accumulator part, it specifies the calculation of accumulator capacity, current, discharge rate, and SOC, state of charge. Okay, till how much that batteries are holding charge. Okay, motor speed. We have already mentioned that the peak speed is around, as we can see the red line, it is 5800 RPM. For the accumulator pack, the maximum power is 16,000 watts. The current is the peak rated current. We can see as the red line in the graph, it's 230 amperes. It shows you around 230 amperes. The accumulator, as far as the configuration is concerned, that's why we have chosen 20 lithium NMC cells are arranged in series and one cell in parallel, right? Okay, this specifies the accumulator discharge rate, how much time it is taking to discharge. I mean, how is the economy of the vehicle. So these are the different results related to motor and accumulator. Discharge rate, to specify the mention, the peak discharge rate is when the motor is in the performance mode, highly performance mode, it's 3.1 C. Motor selection. Okay, before procuring the motor, we have compared from among different vendors, and we found that Golden Motors has been like, it's a 3-phase AC motor, has been like on point on all, like matched all the departments, all uh, checked all the boxes in concurrence with the upcoming competition we are going to take part in. So that's why we chosen Golden Motors HPM 500 series. So this is the motor, okay, motor controller selection. So for this, we have also compared from different vendors. So in case of, we also firstly we taken into consideration the Kelly controller, but after comparing it with Golden Motors HPC 508 series, that we got an overall score 308, which is much more than the Kelly one. That's why we opted for Golden Motors. For cell selection, this time we have selected, yeah, VPW, NMC prismatic cells. Okay, to for because it has got more surface for heat dissipation. It has got less complexity. It's also helped aided us in reducing the overall vehicle weight, and it was also procured at a low price, so it was quite economical for us. For BMS, we have gone for Orion BMS2, since you can see in the list that it checkboxes uh, all the desired factors which our team should have taken into consideration for the upcoming competition. That's why we've chosen it. So these are the various components. HV components mentioned over here: the fuse, particularly 250 amperes, contactor 300 amperes, high voltage wire. Its thickness is around 0 AWG. So the component list is, we have already mentioned. The motor is, okay, HPM 10 kilowatt VLDC motor. Controller is HPC 500H series. The cell we have selected is lithium polymer NMC power cell. And BMS is like Orion BMS, consisting of like 24 cell configuration. Okay. Cooling system has been simulated on MATLAB itself using Simulink. So this, for the cooling plate configuration, we have used cascaded cooling effect, right? So it can alternatively cools the entire cell pack uh, on the basal rate, since it's been placed on the basal area below the accumulator pack. Similarly, the heating cooling unit, it controls the amount of refrigerant getting circulated through the tubule, which is embedded inside the basal region in the cooling plate. So here is our basic typical accumulator design, which is situated. This box is typically situated at the rear end of the vehicle. Okay. So here, this is how our cooling plate looks like. This is the tubule through which coolant runs. It has been located at the base of the accumulator. So to increase the cooling efficiency, this is the battery mesh. Okay, this depicts the overall scaffold of the battery. That's how the battery is gonna contain of a single cell, the single prismatic cell. So for the drivetrain, we have selected a closed gear open differential drive. Like its gear ratio is around 10:1. These are the other figures. Resistance 7.35, power is 4500 watts, RPM is 600 RPM, motor RPM is 5800 RPM. The torque is, we are getting a nominal torque of 7.4 Newton meters, and the acceleration is 1.56 meter per second square, and the total force is 319 newtons. Okay, for conclusion, this year we are trying to be more environment friendly and economic for our budget as well. For the future work, for future we have decided to develop our own drive cycle for simulation, and also we have taken into account the like to increase the efficiency and economy of the vehicle. We are taking into account the frictional losses, and also uh, trying to altering the coefficients to some extent. And also one of the most significant things, since we're using this prismatic cell, so we'll try to minimize the gas buildup tendency from arising from those kind of cells. Okay. This marks the end of our presentation. Thank you. Any questions are welcomed, duly welcomed.